Hello, this is Mr. King, and this is lesson 6.5, Graphing Inequalities in a Coordinate Plane. Before we get started with graphing inequalities in a coordinate plane, we're going to do a quick review of slope-intercept. The slope-intercept form is a linear equation that is in the form of y equals mx plus b. Now, I want you to remember this from our previous studies. When you see y equals mx plus b, m is always the slope, and the b is the y-intercept. And I want you to remember that the slope on a coordinate graph is the rise over the run, and the y-intercept is the point where the line crosses the y-axis. So we need this information as we move forward in our work with graphing on a coordinate plane. So let's do an example of graphing an equality on a coordinate plane. The equation is y equals negative 2x plus 4. Remember when we said y equals mx plus b, the slope is the negative 2 and the y-intercept is the 4. So as we graph this, we know that the y-intercept is 4 units up on the y-axis, and the slope is a negative 1, and the slope means we're going to go down 2 and over 1, down 2 and over 1. When we have the enough points, we can connect the dots there, and we have a slope that is in the negative direction. Remember, if we have a negative slope, it's always going down. A positive slope will always be going up in the positive direction. Okay? Now, let's take a look at an inequality that we'll be graphing in the coordinate plane. Let's go over a few things. Graphing an inequality, we graph on the coordinate plane just as if it was an equality. The only difference is this time we're going to shade appropriately. So let's take a look at an inequality, but in all reality, this is the same one we just completed that was an equality. The only thing we substituted was a less than symbol here. So it says y is less than negative 2x plus 4. We find our y-intercept, which is here. Our slope is down 2 and over 1, down 2 and over 1. We connect our dots, but what we are going to note here is that since it is a less than symbol, it is a dotted line for our graphing here. And what we're also going to see is that we're going to find all the points that are less than negative 2x plus 4. All the ones that are shaded in will be shaded below the line, okay, for graphing an inequality that has a less than symbol. Moving forward, let's take a quick look at what's really important with graphing these inequalities. Here's your very important concept for this unit. When you are graphing, if you have a greater than and less than symbol, whichever one you have, but it's not an equal one, then we say we use a dotted line. Okay? If you have a greater than or equal to or less than or equal to, we use a solid line. Okay? When we look at shading, for greater than and greater than or equal to, we shade above the line that you draw. And for less than and equal to, we shade below the line. Okay? So here's a quick example. We have y is greater than or equal to x plus 1. Our y-intercept is the 1, so we go up 1. And our slope is a 1 because there's no number in front of x. And remember, if there's no number, our slope is determined to be 1 over 1. So you go up 1 over 1, up 1 over 1, up 1 over 1. It is a greater than or equal to, so we have a solid line, and we're shading above, and we shade that way here. So let's substitute a value in and see if it works here. Okay? Let's go up here, and let's say we have the number 10, which is a y. Okay? Is 10 greater than or equal to x plus 1? Let's pick a value over here that is an x value. Let's pick negative 5. If we say 10 is greater than or equal to negative 10 plus 1, we have 10 is greater than or equal to negative 9. And that would be a true statement. And that